Serverless is a topic that has dominated conferences over the last 2 years. But what is it that we're really talking about? Does it mean no servers? Well, as you might imagine, not really. However, it's a very different way in which you can think about the server. The cloud provider transparently acts as the server, dynamically managing the allocation of machine resources. So what does that mean, really? It means that typically when you've created a server, if you think about the most laborious way to do it is you bought a machine, loaded the software, configured, maintained, patched, updated, all of it you're looking after yourself. Now, if you're looking at a VM, you have something that's more agile, someone powers that environment. You don't have to think about the data center. There's less concerns for you. You could come up with some mechanism through which you could have failover. You could use some of the tools of the cloud. However, you still have to maintain that VM. You have to patch that VM. You have to look after it. You have to pay a monthly fee for it. If you think about containers, something similar happens. You have more agility, better packaging, easier deployment experience, but you still have to have that on some machine. You have to pay for that machine. When it comes to serverless, none of that environment, the supporting environment, is necessary. You're writing at the function level. So if you think about an authentication, you're simply going to call that function, and that function is going to return true or false. It's the person authenticated, yes or no. You would simply keep your concerns to that function. The machine that it was running on, the operating system that it was running on, the patching that would need to be done for that, how is that maintained over time? None of that are things that you'd have to worry about. So from a developer perspective, and here's an example of a type of function. This is in fact an AWS serverless Lambda function that I wrote that simply returns a random number. From a developer perspective, this is as easy as it gets. You don't have to think about anything other than your logic, and you're working at a granular level, which means that if you were potentially calling these functions from your browser UI, you wouldn't have to actually create a server. You would simply call directly to this function. And so that's what's often meant when people say a serverless model. And here's a similar one this one is from Google. These are called cloud functions, but it's the same idea. This has really hit a sweet spot. As I mentioned, developers really enjoy this type of functionality. It removes a tremendous amount of concerns from you. It passes it on to those that are better at it, operating, patching, maintaining that environment. And so because of it, we're now seeing a lot more functionality being offered in the same way. As you can see here, this page is from Google, and these are some of their serverless offerings. And they have databases, they have AI, they have many other things. And if you think about AI, for example, this is a perfect type of packaging. You do not have to concern yourself with the implementation of the algorithm, the maintenance of the environment that it's going to run in, the performance, all of that you can simply specify as you fill in your terms that you are requesting for that function, and you can simply call that function. Say you were doing you were trying to do sentiment analysis or NLP, you would simply call the function, pass in your data, receive the output, and not be concerned with the implementation, the maintenance, the updating of the platform. So this is now being offered by all the major cloud vendors. You can see here some of the offerings from AWS. There's compute, storage, and analytics, you name it, being offered in the serverless model. And as you might expect, the same is true for Azure. You have compute, you have storage, and on, just like you do from the other vendors. Now, an important feature to note here is that in this model, you're simply paying for execution time. As I mentioned before, if you're running a VM, that VM runs the whole month. You have to pay for all of the use of the month, even if you're only using it 1% of the time. The same is true for containers. And yes, you could come up with schemes in where you would take things down and bring them up. But again, that's at additional cost. Those are additional things you have to maintain. So the traditional model is you turn it up, you turn it on, You pay for it the whole time, and this is inefficient. In this case, because you have a different environment, a different context, you're simply paying for the execution time. And that's very, very efficient. If the feature that you put together or the function that you wrote turns out to not be needed most of the time, then you're not paying for it. If it's hit all the time, then you know, and you can evolve it accordingly. But this is a very attractive pricing model, and in fact, for most of the cloud vendors, they include up to about 1 million calls per month for free, meaning that it is that attractive for them, and they are that good at provisioning the environment that they can provide that amount of functionality for free. Now, the other thing that you might hear often as well is Lockin. There are some really negative comments that I've seen on the press. For example, this one: serverless is one of the worst forms of proprietary lock-in we've ever seen in the history of humanity. This one comes from the Register. However, when it comes to the platforms that you're writing on, keep track of some of the underlying technology. There are some open source offerings, and if you're closely aligned to the open source technologies, especially those that have been recognized by the Cloud Native Foundation, then you're in a good spot. So for the most part, when it comes to portability and serverless environments, you can think of Docker plus Kubernetes. Docker gives you that encapsulation. Kubernetes gives you that fabric you can deploy in robustness that is well known for. And so on the back of this, we have a technology that is called Function as a Service, and the open source implementation is Open Function as a Service. And you can use it readily from most of the cloud vendors. It's up to you whether you want to trade off some of the initial evolution of the technology and lack of full featuredness that you might find in the commercial counterparts versus what you might get and some of the lock-in you might have. You should also be smart about how you're storing your data, and that could bring additional trade-offs, meaning that if you are well encapsulated, if you're not depending on the specific implementations of the cloud vendor you're in, then you can continue to have the same flexibility and take advantage of the performance and the features that are offered through the proprietary, so-called proprietary services. When it comes to the open function as a service stack, it is pretty performant. This is pretty much a thin layer over Kubernetes and Docker, as mentioned, and you can see here that you could even run it on Raspberry Pis. So this is certainly a very attractive option. It simplifies a great deal of what you do. We use it often because it simplifies our stack and it reduces the amount of testing that we have to do. But be careful that you don't get yourself into a proprietary situation where you have a high lock-in.